Problem 17. We're basically given three complex numbers, 0, z, and z to the third, and we're trying to find the number of ways that they can be graphed in the complex plane such that they're the vertices of an equilateral triangle. So first of all, this is the complex plane. This is the real numbers, this is the imaginary numbers. For every quantity, z, that's equal to cosine theta plus I sine theta. And the theta represents the degrees of rotation. So for instance, if theta is equal to 60 degrees, that means that with respect to the origin, this is 60 degrees. So, given this information, how do you solve the question? So, we know that this first point, 0, well, that's very easy to understand. That's just the origin. But what about z? Well, let's say that z was somewhere here. That's the point. That's the complex number z. So, z, with respect to the origin, has to have 60 degrees. So, we'll keep that in mind for now. Now, let's consider the second one. An equilateral triangle always has 60 degrees. So you can imagine it as taking this, rotating it 60 degrees to here, rotating it 60 degrees, and again. So if I were to rotate this side length by 60 degrees, I would get z to the third. And that's terrible. It will probably look something like that, right? To z to the third. And the reason why I'm doing this is because for any question, you want to relate given information together. So this relates z with z to the third, with a 60-degree angle rotation. So if I were to have this understanding, then that means that z minus 0 vector with z to the third minus z vector has to equal a cosine of pi over 3 rotation with respect to the origin. And the reason why for this is very simple to explain. Z to the 0 in itself, z minus 0 gives a vector, because a vector by definition is equal to the endpoint minus the initial point, right? So initial. But in the case of the complex, we just substitute x with cosine and y with I sine. So if we were to subtract out z with 0, that will give you a vector, which is this vector right here. And if we were to have that vector, we want to rotate it 60 degrees. And if we were to rotate it 60 degrees, whatever that is, it would get a new vector, which is z to the third minus z. That's the one we established. But dividing the vectors out will give out the angle that it shares. That's just a property of vectors. And since we're working in a complex plane, we must relate it to z, which is why we have cosine of pi over 3 plus I sine pi over 3. So given this information, we can solve for z, because remember, z is just like any other variable. So z to the third minus z over z is equal to that, so that's equal to z squared minus 1. So z squared minus 1 is equal to cosine of pi over 3 plus I sine of pi over 3. And if I would have to have that, that means z would be equal to the square root of 1 plus cosine pi over 3 plus I sine pi over 3. So what is the square root of a complex quantity? Well, square roots of complex quantities always have two solutions, because that's a property, where one solution will be positive and another solution will be negative. So if I were to have the square root, I don't really care what it is, because I'm just trying to find a number of solutions. I don't care about the specific solutions. So I'll always have one quantity that's positive, another quantity that's negative. So that's the first case, where we only rotate it by pi over 3. But what if we rotate it by 2 pi minus pi over 3? If you were to rotate it by 2 pi minus pi over 3, you can imagine us just going clockwise. And that would create a equilateral triangle that looks like this, as compared to this. So we have to consider the second case, which is that z squared minus 1 can also equal to cosine of 2 pi minus pi over 3, which is just what, 5 pi over 3? And plus I sine pi over 3, or 5 pi over 3, which can be the same thing as just a negative pi over 3 rotation, because that's clockwise. So in other words, we have another positive and negative pair because we have another z. So we have 2 times 2, which gives 4. So in total, we have 4 solutions, bringing you to answer choice D.